Hello and welcome to York Observatory's weekly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube now broadcasts every last Friday of the month at 7:30 p.m. Eastern Time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and Facebook at Alumni Carswell Ops. Good evening, everyone. I'm Maheen and I'll be one of your hosts this evening along with Zena. We're here from the Alumni Carswell Observatory at York University. Tonight, we've got a special guest speaker, Paul Mackin, who will be talking about the mission to a metal asteroid Psyche. I will be introducing our guest speaker for tonight shortly. I would like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. I will now hand it over to Zena so she can tell you all about what's up in the sky this week.
Hello everyone! Before we jump into our main event, let's take a moment to discover what's happening up in the sky this week. Today over Toronto, sunset was at 6:16 p.m. Eastern Time. And as the sun slipped below the horizon, the moon took center stage in its waxing gibbous phase. This means the moon is more than halfway illuminated, though it hasn't reached its full brilliance just yet. However, it's shining at a striking 98% illumination. But the real lunar show is set for tomorrow, October 28th. Brace yourselves for a stunning full moon that will grace the night sky. It will rise as the sun sets in the east and accompany us through the night, setting with the sunrise in the west. During a full moon, it's spectacularly 100% illuminated, positioned on the opposite side of the Earth from the sun. This precise astronomical moment is measured down to a fraction of a second. And here's an interesting fact. The time between two full moons is known as a synodic month, and it is approximately 29.53 days long. Tomorrow's full moon also brings an extra treat, a much-anticipated partial lunar eclipse. This celestial event will be visible across Africa, Europe, and Asia. Observers in these regions will witness a portion of the moon slipping into Earth's shadow with a maximum of 12% of the moon's diameter inside Earth's shadow. The best part is that lunar eclipses are safe to photograph and watch without the need for eye protection. For those with a keen eye, keep an eye out for the bright planet Jupiter, shining in close proximity to the lower left of the moon. This creates a captivating view, especially when using binoculars. And back in Toronto, the International Space Station, or the ISS, made a brief appearance earlier today. It was visible at 5:06 a.m. for less than a minute, and then again at 6:39 a.m. for 4 minutes before disappearing at 10 degrees northeast. As the waxing gibbous moon gracefully descends in the western sky, approximately 1.5 hours before sunrise, early morning sky enthusiasts are in for an enchanting celestial viewing. Direct your gaze towards the Lynx constellation, positioned just to the left or northeast of the Gemini twins, Castor and Pollux. While Lynx may not be home to any Messier objects, it does showcase a fascinating globular cluster known as NGC 2419, and it's affectionately dubbed as the Intergalactic Wanderer. This particular globular cluster is impressively distant, residing approximately 300,000 light years away from us. Despite its remote location, it remains visible through a medium-sized telescope, offering a captivating sight for sky watchers. It also spans just 4 arc minutes and showcases a bright, compact core. Even with a small telescope, you might catch a glimpse of it. Larger telescopes will reveal more detail and may even begin to resolve some of the few stars visible around the edges. Astrophotos display its mottled blue and orange appearance, as this cluster hosts 2 very different populations of stars, making it quite unique for a globular cluster. If you're looking for an additional celestial target, Castor, Gemini's alpha star, is a captivating binary star with 2 components of nearly equal brightness, making it a fantastic subject for amateur astronomers. Enjoy these celestial wonders in the night sky this week, everyone, and happy stargazing!
As I mentioned, tonight we've got a special guest speaker, Paul Mackin. Paul is a first-year student in the Astronomy and Astrophysics program at York University. Before he began his current course of study, he was a successful telecommunications engineer and entrepreneur. He has been an enthusiastic amateur astronomer and follower of space programs since the 1960s and is also currently volunteering at the AICO Observatory. If you have any questions for our speaker, you can drop them in the YouTube chat and Paul will be able to answer them at the end of the talk. Without any further delay, I will now hand it over to our guest speaker for tonight.
Thank you so much. I'm just going to get my screen sharing thing. I've been told that only the host can share on this meeting. Technical problems. Okay, good. I think we've got it. There we are. Okay. And hopefully my screen is now visible. Okay, so I'd like to talk today about a mission to a metal asteroid. This is the Psyche spacecraft, which is en route to 16 Psyche, which is an asteroid of the same name, 16 designating that it was the 16th asteroid discovered. So there's a lot of news about asteroids these days. NASA has crashed spacecrafts into asteroids, and that happened just a year ago. Just a couple of weeks ago, the OSIRIS-REx delivered NASA's first asteroid sample to Earth. And then going back a little further, NASA's not the first to deliver asteroid samples to Earth. Japan has done it twice. And you can see a headline here from 2000, and they did it once with a very small sample, just a few micrograms a couple of years before that. So what are asteroids and why are we visiting them? So asteroids are small bodies in orbit around the sun, and small is relative. The largest are up to 1,000 kilometers in diameter, but they're not planets, but some, just a few, are considered dwarf planets like Pluto. And don't want to get into a debate about the whole Pluto as a planet thing, but it's a bit smaller, and some of these asteroids are actually bigger than Pluto. They are not moons because they orbit the sun, but they're not one of the so they orbit the sun, not one of the 8 planets. So, the moon is the moon because it orbits the Earth. But if you look, there's some ambiguity about this in a sense, because both of Mars's moons Phobos and Deimos, are possibly captured asteroids. And we'll get to why that is the case in a moment. But while some asteroids are larger, many are quite small, under a kilometer in size. And broadly speaking, asteroids are in orbit between Mars and Jupiter in a place called the asteroid belt. Now, here's a picture of some sample asteroids. The biggest one here is number 4, Vesta. It was the 4th one discovered. These are all pictures that have been taken by spacecraft. The very first asteroid ever imaged by a spacecraft is the one sort of in the middle there on the right, 243 Ida, and its moon Dactyl. And yes, asteroids can have other asteroids as moons. And that was taken by the Galileo spacecraft en route to Jupiter in the 1980s. So, we've visited a fair number of these bodies now. We're adding more to our exploration list all the time. Now, people think, oh, asteroids like Star Wars, spacecraft smashing into rocks and evading other spacecraft by hiding in the asteroid belt and caves and so on. Well, not exactly. Actually, in fact, nothing like Star Wars at all. The asteroid belt is mostly empty space. There's between 1 and 2 million larger asteroids, and by that we mean greater than a kilometer, and many million smaller. Volume of the asteroid belt is 16 million trillion cubic kilometers. So the average distance between asteroids is approximately 1 million kilometers. It really is just a big desert with occasional rocks showing up. It's a space desert. So why do we care? Well, planetary defense for one. These things do hit us. One of my favorite quotes is from a great science fiction author named Larry Niven, who writes hard science fiction, and by that I mean it tends to emphasize science rather than fiction. But his quote is, "Dinosaurs became extinct because they didn't have a space program." And what he means by that is, in the age of the dinosaurs, 65 million years ago, an asteroid hit the Earth and in the Gulf of Mexico and wiped out a large percentage of the life on the planet, including the dinosaurs. If they'd had a space program, maybe they could have done what we're trying to do, which is protect ourselves from errant asteroids. So there are other numerous reasons for interest as well. Some come very close to Earth and sometimes hit, so planetary defense. They can also tell us a lot about the formation of our solar system. Our solar system formed, we believe, from a large cloud of gas, and a bunch of that, concentrated in the center, which became the sun as further mass accrued, and you ended up getting the sun. Then you had other gas in orbit around that, and there was a accrual there as well, and that formed the planets. And then there may have been some leftover material, or another planet may have tried to form and failed to form, and in the region between Mars and Jupiter. So they may be the remnants of a failed planet. Now, when we look at asteroids, we see a bunch of different types of asteroids, which we'll talk about in a minute, but certain types of them may contain some key compounds found in life. And they also contain resources, just like Earth has resources. Earth is made of the same basic material as asteroids are, maybe with more water or whatever, but because we all came from the same large gas cloud, the same elements that are found in Earth should be found in asteroids. So there's resources there. Also, asteroids are kind of cool. There's a lot of things to visit. They're very different. They make for great visual images. So they're kind of fun. So let's talk about space Psyche, which is both the spacecraft in this case and the asteroid. So the spacecraft was launched, actually I've got a mistake here in my deck. It was launched on October 13th, just 2 weeks ago today. And it features, and we'll talk more about this in a minute, solar electric propulsion. Well, again, that's kind of a bit unusual for a lot of spacecraft now, and NASA's going to be using more of it, as are the Europeans, but it offers certain advantages, which we'll discuss in a moment. It is operated by NASA and the Jet Propulsion Laboratory, and the Jet Propulsion Laboratory, if any of you have seen the movie The Martian, the whole NASA thing that happens back on Earth is JPL. It's nearly a 6-year cruise to target. That includes a gravity assist at Mars and gives you an arrival at Psyche in 2029. It's a long way away. It has solar panels which generate, and you can see them at the side of the image here in the sort of X patterns on each side. They generate 20 kilowatts of power at Earth. But when we get out to Psyche, which is pretty far out in the solar system, it's a lot further away from the sun. Solar intensity is much lower, so they're only generating 2.3 kilowatts, roughly a tenth of the power. But it is enough for the instrument suite, which is an imager and a spectrometer and a magnometer. Okay. So we launched it 2 weeks ago today on the Falcon Heavy. It's only, I think, the 8th time the Falcon Heavy is launched, and it's the first NASA launch for the Falcon Heavy. Now, everyone's seen the Falcon spacecrafts fly. They're individual rockets. This is 3 of them strapped together with basically a payload on top. The 2 side boosters returned and landed on Earth, and the central core was expended. But it is designed to give a very solid push out of Earth's orbit towards Psyche. So the asteroid itself, Psyche, is approximately 250 kilometers in diameter. It has not been imaged yet, other than by radar or some very low resolution images by some telescopes, but they're not very clear. This is what the image here is of the radar images of Psyche showing rotation. And you can see there's a bar through the middle of it showing the axis of rotation. It's M class. Now, asteroids come in 3 broad classes. There are C class, which have a lot of carbon. And Bennu, which we just returned samples from, was a C-class asteroid. There's S-class, silica class, which are basically rocky asteroids. They're made from rock. And finally, there's M-class, meaning they have a high amount of metal in their composition. And Psyche is a metal asteroid, basically. The orbital period is 5 years, and Earth's is 1, of course, and the distance from the sun is approximately 3 astronomical units, and Earth is exactly 1 astronomical unit from the sun. So it's about 3 times further away. And it is possibly the core of a failed planet, and I'll explain that. I talked about how the asteroids may be the remnants of a planet that never formed. So think, you've got material in that part of the solar system, it's accruing, coming together in a planet, and then another large object, another protoplanet, hits it and smashes it apart. But as it's accruing, material at the center is being heated. The whole body is gaseous or liquid. It's being compressed, and the heavier elements will sink to the core, which is why Earth has a metal core. So you start to get metal accruing in the center, then the entire thing is smashed to bits, and you've got this body flying away, which is kind of representative of the protoplanet core. Psyche might be that. We're not sure. We don't know yet, but we'll find out. So something to keep in mind before we get into our next section, though, which is how we get to Psyche. Space, this is one of my favorite quotes. It's meant to be comedic, but it is actually incredibly perceptive. Space is big, really big. You won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. This is a quote from The Hitchhiker's Guide to the Galaxy by Douglas Adams. And as I said, it's meant to be comedic. It's funny, and it's a very funny book, but it speaks volumes about the solar system. We can't get places very fast. So how do we get to Psyche? Well, we use solar electric propulsion. When Psyche was launched, it was given a good solid boost by the Falcon Heavy. It's moving out away from Earth, and then it has to it can either go in an orbit, which will get it to Psyche eventually, or it can change things along the way by firing another rocket, adding velocity, and so on. Well, that's very inefficient if you use chemical fuels. So what Psyche does is use solar electric propulsion. So the mission starts with enough of a boost to get it on its way. But solar electric propulsion provides a high efficiency way to modify its orbit. So the way it works is that we've got those big solar panels. So they're generating electricity. We've got a big tank of a gas called xenon on the spacecraft. We've got 1,000 kilos of that amount of that gas. That gas, it's a heavy molecule. It's injected into an engine, and then the electricity ionizes it, which causes it, moving through a magnetic field, to eject from the back of the spacecraft. Now, the total thrust is the equivalent of a AA battery sitting on your hand. It's not very much, but it adds up. So think of it this way. If you're moving at 100 kilometers an hour in space and there's nothing to slow you down, and every second you add a millimeter of increased velocity, after 1,000 seconds, you're going 101 kilometers an hour. After another 1,000 seconds, you're going 102. After an hour, you're going 103. That's just a rough example, and the math isn't exactly perfect, but it's just to be illustrative of how this works. And the thing about these Hall effect engines is you don't run them for a few seconds or a few minutes or a few hours. You run them for days or years. So this is how we get there. You don't fly straight there. Orbital mechanics makes the journey long and complex. We start off with a cruise phase. So that would normally be putting Newton in charge, but in this case, after launch, we start thrusting with our solar electric propulsion. We thrust almost till we get to Mars. Then Mars grabs the spacecraft in its gravity and slingshots it around Mars, and then we start thrusting again. And we thrust all the way out until we're about 100 days from the asteroid, and then we go into orbit with a lower level of thrust. 6 years of flying time, but this is a very efficient and reasonably quick way to get to Psyche and get into orbit. And then when we get there, we start by checking the place out. Leading to our orbit Psyche, the spacecraft spends 100 days in the approach phase. The spacecraft measures the asteroid spin and axis and rotation, but it's also looking for moons or dust around the asteroid. The spacecraft enters orbits. It performs science operations from 4 different orbits and then sends the information back to Earth. So what to expect? Well, lots of pictures. Very excited scientists, geologists, astronomers, astrophysicists, biologists, engineers, rocket scientists. We believe that the Earth, the Sun, and the solar system all form from one common cloud of material. The materials at Psyche should be familiar, probably, but how accessible they are, how much usable material is there. And then NASA over-engineers its spacecraft. They are built to last with extra fuel. There could be an extended mission, which could be more time at Psyche or another asteroid visit or even one more after that. No matter what, be prepared to be amazed. So I've also included, and you can see this here, a couple of reference materials. There's some great links, including planetary radio broadcast just from this week, which talks about craters on Psyche. So these are certainly things worth checking out. And with that, I'd like to thank you for your attention today, and I'll turn this back over to my colleagues.
Thank you. I'll just take over the screen share. All right. Thank you so much, Paul, for coming on tonight. It was an amazing talk. We thoroughly enjoyed it. I will now hand it over to Zena as she has some questions for you.
Perfect. Thank you, Paul, for the very interesting talk. And I was wondering if there are any plans for a follow-up missions or research projects related to the Psyche mission's findings.
Well, yes, I mean, undoubtedly there are. I mean, The European Space Agency is looking at asteroid sample return missions. Japan is doing another. The Chinese is certainly looking at doing this as well. They've got an ambitious space program. So there's a number of different programs. But interestingly, when Psyche was approved, it was approved with another mission called Lucy. And that mission launched about a year ago, and it's on its way. It's going to be visiting 8 asteroids, kind of unique. It's going to be flying by 8 asteroids over a 10-year period. In fact, the very first of those asteroid flybys is next Wednesday, November 1. So that's very exciting. And it's visiting a special class of asteroid. Of the 8 it's visiting, 6 of them are what are called Trojan asteroids, which are in orbit around the sun, ahead of Jupiter or behind Jupiter. So they're at the very outer edge of the asteroid belt. But yes, there's a lot going on in asteroid space science right now.
That's intriguing indeed. So another question I had was, what role do you think the Psyche mission plays in inspiring the public and future generations to pursue careers in space exploration and science?
Well, science in itself is interesting to scientists, of course, and people who have that predisposition. But I actually think that the public gets very enthusiastic about such things. If you think back to the DART mission a year ago, when NASA crashed a spacecraft into the moon of, well, it's a dual asteroid system, one orbiting the other, and they wanted to see if they could change the velocity of the orbital velocity of that little moon, and successfully did so. There was a great deal of public enthusiasm. But you also have to look at this in sort of generational terms, because the science today becomes the technology tomorrow, which becomes the jobs tomorrow. So, for example, one of the biggest things that came out of the lunar landing program that a lot of people don't really think about is today's advanced medical technology, because they had to monitor astronauts' health when they were on the moon and so on. Well, that all led to a revolution in medical technology. So it's not just a matter of inspiring people, inspiring the public and so on. It's also establishing new science, which leads to new technology, which leads to new jobs, which leads to new careers. So it's kind of a beautiful effect, actually. And it's one of the reasons why science education is so very important for our young people today.
Perfect, thank you.
All right, thank you so much, Paul, for coming on tonight. It doesn't seem like there are any other questions in the chat right now, so I will move to the outro. Well, everyone, you have been listening to the Alan I. Carswell Observatory's monthly TeleTube broadcast, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. Thank you once again to our guest speaker, Paul Mackin, for his insightful talk tonight. The hosts this evening have been Zena and myself, Maheen. All of our programs are free, but if you would like to make a donation, see our website at yorku.ca/science/observatory. You can always connect with us on Twitter with the handle @yorkobservatory, and check out our website for show notes, content updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in. Clear skies and have a good night.